Rescue Education, we help you to learn faster, easier, and better. I'm Dr. Christine Brzezowski, and I'm going to help you learn organic chemistry. Today, we'll talk about the nomenclature of alkyl halides, alcohols, and ethers. This video exactly follows my help book. My book also contains extra test your knowledge problems and complete solutions. Here are the pages to find everything. We're going to start with some alkyl halide nomenclature. If you have a halo group in your molecule, it's treated exactly like an alkyl group. It has exactly the same priority. So it competes directly with alkyls in both numbering and in the alphabetical priority. Common names are used very often for the smaller haloalkanes. And when you have a common name of an alkyl halide, the halide is actually the parent. So for instance, in this molecule, the IUPAC nomenclature would be 2-bromopropane, but in common nomenclature, the parent would be a bromide, and we would call this an isopropyl bromide. Pause and try these problems, then we'll solve them together. So the first compound we're going to name using IUPAC nomenclature. And as I said before, the halo groups have exactly the same priority and are considered in exactly the same way as the alkyl substituents. So our parent goes 1, 2, 3, 4, 5, 6, 7. So this is a heptane with 2 substituents on it. Ethyl beats fluoro in alphabetical priority, so this is a fluoroheptane. Leave a little space for the number, and this is an ethyl fluoroheptane. So the last question we have to address is which way to number this. Let's go in both directions because it's not obvious. When you go in both directions, you see that it is a 3,5 versus 3,5, so we can't tell from the numbers. The numbers are exactly the same, and when that happens, you default to the substituent with alphabetical priority getting the lowest number. So ethyl is higher priority than the fluoro, so it gets the 3, and the fluoro gets the 5. The second compound is a simple alkyl halide. We can name it using IUPAC nomenclature. There's 2 substituents, the bromo and the methyl group. So this is going to be a bromo, methyl, propane. So the only question is the numbering, and in this case, and you can do the numbering in the other direction yourself, the bromo will be at position 1, and the methyl will be at position 2. Now this is almost certainly would be called by its common name. It's a simple alkyl halide, so this is called isobutyl bromide, with the bromide being the parent and the isobutyl group being the substituent on the parent. Alcohol nomenclature is very, very important. There's a lot of alcohols that occur in organic chemistry. The rules follow the rules we already know. The longest chain containing the hydroxyl, which is the OH group, is the parent. It may not be the longest chain overall, but you have to pick the chain that has the hydroxyl. The hydroxyl or alcohol has the highest priority so far of any group we've looked at. If you have a hydroxyl, you change the parent alkane name E to all. So the hydroxyl must get the lowest number. So actually naming alcohols is very easy because you just focus on the numbering of the hydroxyl. It's also very common for the hydroxyl to occur with a double or triple bond. If you have a hydroxyl and a double bond, you change the ane ending of the parent alkane to enol. If instead you have a triple bond with your hydroxyl, you change the ending to inol. Cyclic alcohols are also not too bad to name. The hydroxyl must get position 1 because it is the most important group that we have studied so far. If there's any ambiguity, then you go to the next highest priority groups, which are double or triple bonds. And finally, you can consider alkyl and halo groups if everything else, the numbering schemes are exactly the same otherwise. Pause and try these problems, then we'll solve them together. The first molecule has a hydroxyl. It is the highest priority group in the molecule, so this has to be named as an alcohol. And the parent chain must contain the hydroxyl. So even though the longest chain actually snakes through here, we have to choose the chain that contains the hydroxyl, and it's this chain. And remember that the hydroxyl must have the lowest number, so we can already see that we're going to be numbering from right to left. So this molecule has a propyl group, a methyl, and a chloro group, and it has 7 carbons. So this is a heptane if it were an alkane, but we change the parent alkane name by changing the E of the heptane to an OL. So this is a heptanol. Then we know that the hydroxyl is at position 2. We have 3 other groups. We have a chloro, we have a methyl, and we have a propyl group. So the propyl is last in alphabetical priority, so we put it before the 2-heptanol. And so we have the propyl, we have a methyl, and we also have a chloro. The numbering system is set, so the propyl occurs at the 3 position, the methyl occurs at the 5 position, and the chloro occurs at the 6 position. So when you have an alcohol, the numbering becomes very, very easy. The second problem has an enol, so we have to name this using both functional groups. Again, the double bond is lower in priority than the hydroxyl. So we number to give the hydroxyl the lowest possible number. This is a 6-carbon parent chain. That means it's a cyclohexene parent, and we call this a hexene. Leave a little space for the numbering of the hydroxyl ol. We do have a substituent. We have a methyl substituent here. So this is a methyl hexenol. The last thing we need to do is simply assign numbers. We give the alcohol the number 2. The alkene occurs at the position 4, and the methyl occurs at position 5. So the numbering, very easy, because we really just focus on the hydroxyl position. The last example is a cyclic alcohol. It's also a hexenol, so we're going to have to take that into account. And we have 2 methyl substituents on here. So this is a cyclohexene ol. Okay, so this is a cyclohexenol, and it also has the dimethyl substituents. Now you notice that I didn't leave a space for the OL, for the alcohol designation, because the alcohol is the highest priority. it must get position 1. Then the double bond has the next highest priority. So we have to number to give those the next, that alkene, the next lowest number. And finally, the alkyl groups have the lowest priority, so we worry about their numbering last. So this is a cyclohexenol. The double bond is at position 3, and the dimethyls are at position 6, 6. So we have to talk about the common names of alcohols, and these are used a lot because alcohols have been around for a long time. So for the simple alcohols, we name it as an alcohol parent. So this is methyl alcohol, ethyl alcohol, and isopropyl alcohol. So those are used very, very often. If you have 2 hydroxyls, and there's lots of compounds that do, this is called a diol, and we change the ane ending of the corresponding alkane. We don't change it, actually. We just add the word diol. If you have 3 hydroxyls, you simply add the word triol to the end of the parent alkane. So for instance, these 3 molecules all have more than 1 hydroxyl. The IUPAC name of the first compound is 1,2-ethane diol, but it is known much more commonly and almost exclusively as ethylene glycol, which is of course an antifreeze. The second molecule is 1,3-propane diol, and the third molecule, 1,2,3-propane triol, is known again almost exclusively as glycerol, very important molecule in biochemistry. The last functional group we cover the nomenclature of is ethers, and we're going to first look at its IUPAC nomenclature. An ether is named as an alkane parent with an alkoxy substituent on it. So an alkoxy substituent is even lower priority than a halo or an alkyl type of group. So you look at your ether, you look at the larger side of the ether and the smaller side. The larger side will be the parent alkane, and the smaller side of the ether will be a substituent on the parent alkane. Alkoxy substituent is derived from an alkyl group, the name is. You change the YL of the alkyl group to the suffix oxy. So for instance, an ethyl is changed to an ethoxy substituent. Pause and try these problems, then we'll solve them together. The first problem is fairly straightforward. You can easily see that the ethyl group is the smaller group, so it will be a substituent on the longer alkane chain, and the longer alkane chain is a pentane. So this is simply going to be a 1-ethoxy pentane. The next example is a little bit more complicated, but anytime you see this OH, that means that the alcohol must be the parent. So the parent here is ethanol. And the ethanol has a methoxy substituent on it. So this is simply called 2-methoxy ethanol. And finally, even though we have not yet covered benzene nomenclature, that'll be in second semester, you can see that this is simply a benzene with 2 ethoxy groups on it. The only question is numbering, and you should intuitively know that you want to go the short way around the ring. So this is a 1,3-diethoxy benzene. Okay, we have to talk a little bit about common nomenclature of ethers. There is a lot of it. Simple ethers are only really referred to as by their common names. And the format is you put the name of the first alkyl group in alphabetical priority, leave a space, name the second alkyl group, and then leave a space, and then put the word ether, so it's 3 different words. So for instance, this molecule is called tert-butyl ethyl ether, and B beats E. This molecule is called benzyl methyl ether. And the last molecule, very, very common, is called diethyl ether. When people talk about ether, without specifying which one, this is the one. This is the one that's used as an anesthetic and also as a very common solvent. Cyclic ethers are named in IUPAC by putting the prefix oxa in front of the corresponding cycloalkane with the same number of atoms. So for instance, this is an oxacyclopropane in IUPAC nomenclature. However, we know it almost exclusively, and we will use it later in the book, as ethylene oxide. So this is usually referred to as ethylene oxide. Sometimes also another common name, it's called oxirane. A final very important cyclic ether is oxacyclopentane, but it is known as tetrahydrofuran. It's a very common solvent, so you'll be seeing this molecule a lot. If you found this video useful, you'll love my new Organic Chemistry Help book. It takes the essential topics of first semester organic chemistry, puts them into discrete units with concise and crystal clear explanations and many sample problems. But the best thing of all is it has test your knowledge problems. So extra problems that help solidify your knowledge, and all the solutions are included at the back of the book. If you're interested in my book, go to my website, rescueedu.com.